Welcome to our video on 5.5. So we just finished all our sections talking about the binomial distribution, some general ideas about distribution. And in 5.5 we switch our idea for the rest of the chapter. 5.5, 5.6, and 5.7 are all going to deal with continuous distributions. And we can tell this right away because if we look at this page, we notice that we have graphs rather than tables. When something is continuous, then we have to use a graph to display it instead of a table because we cannot just write down discrete chunks of information. We use a graph. And so today we'll begin that discussion of how do we get a mean, a median, a probability from a table. So we're going to talk about two different distributions today, two different graphs about how employees could be paid at particular companies. Obviously this is made up, but each of those are examples of distributions that have names. So first, uniform. The idea of uniform is everything is the same. In a uniform probability, all the probabilities are the same. And so we get something that's straight across. So there's our first distribution. If we look first, mean and median, we notice that this, while it's straight across, is also symmetric. So our mean and median are going to be directly in the middle here. And so we find what's directly in the middle of this, 15 and 25. Our mean and median are both going to be at 15 because we have a symmetric distribution. Is this valid and why? So we remember back to when we started talking about probabilities. Our probabilities were valid if they add to 1. Now we don't have addition because we have a graph. Now it's an area. So this is an area of a rectangle equals the base times the height. And we want this to equal 1. Here our base is 25 minus 5 is going to be 20. A height of 0.05, 20 times 0.05 is equal to 1, and so this is valid. Then what if we want a probability? And this is our new strategy, which is going to be when we want probability from a graph, equals area under the curve. Under the graph, this is going to be a straight line. And so if it says probability from 0 to 10, or from 10 to 15, take out a color or highlighter, and we estimate roughly where 10 is on the graph, where 15 is on the graph. So probability is going to be area underneath that curve. That means we want the area of this shape here. It's also going to be a rectangle because the original is a rectangle. This is going to be a rectangle as well. And so we want the area of this rectangle. So again, base times height, and then we look at this and we say which of these represents the area here. Here we've got a base of 5. 15 minus 10 is 5. So 5 times the height is still 0.05. And that gives us an area of 0.25, and that is the same as the probability. So that's a key skill, and that's a really important one. No matter what the shape of the graph, if we want a probability from a graph, it's going to be area underneath the curve. The second half of 5.5 deals with bell-shaped curves. We've seen this a couple of times. This is going to get a big star because the bell-shaped curve, which we are going to call the normal distribution, and looks like this, is going to be our most important distribution for the rest of the course. So we introduce it now, and then we use it every chapter the rest of the way. On this one, I'm giving you that the mean is 15 and the standard deviation is 5. We see right away that the graph is symmetric, so we know that the median is going to be in the same place. But what we're going to do here is we're going to label this graph. And this is an idea that we've talked about a little bit before, and that the middle of this graph here is the mean. And then these lines here that I've labeled on the graph for you, you see 1 SD, 2 SD, 3 SD. Those are the standard deviations. So every time we go out approximately this far, it's not something that you memorize, but you have an idea of about this far in the graph, that's going to be one standard deviation above the mean. So we think 15 plus 5 is going to make this 20. Or if we go the other way, minus one standard deviation, 15 minus 5 is going to be 10. And then we label this next here. We go another 5, 25. We label this one next here. This is going to be minus 2 standard deviations, so 15 minus 10, or minus 5 is 10, minus another 5 is 5. Go out. And what we're going to do is we're going to have a lot of 1s in 5.5 where you label out to 3 standard deviations. So here's the mean, 1 standard deviation, 2, 3 standard deviations. 15, 1 standard deviation, 2, 3 standard deviations below the mean. We'll do a lot more later with finding probabilities from a normal distribution, but that's in 5.6 and 5.7. So right now we're going to start by labeling this picture with the mean and standard deviation going out that far. And at this point, we remember that we've got 3 types of distributions with names. They are the binomial that we talked about in 5.3 and 5.4, uniform, which is when we look at that graph that's a rectangle, and obviously there's a little bit more to Chapter 5 than this, but these are the 3 distributions that have names, and we want to keep track of those names for ourselves to keep Chapter 5 organized.